The scientific method. So the scientific method is basically just how people solve problems. This can be formal, step-by-step written process with lots of data collected, or an informal, just to guess and check. This is not just used by scientists. Basically, anytime you guess and check, you've used the scientific method. For example, you might be wondering, where's my phone? Maybe it's somewhere. That's you identifying a problem, and that's you making a hypothesis. When you go and check, that was you basically doing the experiment. And then afterwards, you're like, it's not here. You've analyzed the data. You collected the data. It wasn't there. You've analyzed it. Yep, wasn't there. Where else could it be? Now you're back to making new hypotheses. The steps can go out of order. You don't need to follow it step by step every time. Like I said, it can be an informal process. It's okay to go out of order. So what does the scientific method look like? The scientific method, basically you start out figuring out a problem, and you form a hypothesis, which is an educated guess, and you make your predictions. This is where I think maybe it might be. This is what I think will happen if I do this. You plan an investigation. You plan what you're going to do, basically your experiment, and then you identify your variables, the thing that you're changing, the things you're not changing, what you're going to be measuring in the experiment. Then you organize and collect your data. This is the actual doing the experiment part. And you interpret and analyze your data. You say, what does it tell me? What did I learn from this? From here, you can make a conclusion. Your conclusion might be that you need a whole new hypothesis, or it can be that you're going to collect some more data. Now, this collecting more data, this repetition, this is what good scientists do. Anytime they do an experiment, whether it was right or wrong, they'll repeat it again. So the scientific method acts much more like a cycle than a step-by-step 1 through 10 or 1 through 8, or how many steps you break it down into process. It's much more of a cycle. It flows back and forth, in and out, together with whatever part you need right then. But what happens when scientists are done? They've collected tons and tons of data. This is it. This is what happens. So then what? They will always, always, always share their results. And there's so many different ways they can share it. They can share it on television. They can share it in a peer-reviewed journal. This is like a special magazine for scientists based on, just a specific topic. A really famous one is like the New England Journal of Medicine. So these are doctors, people who do some sort of research within medicine. They publish there, and it's a really big deal to be published in a peer-reviewed journal because that means your peers, so people who do just what you've done, have looked at your work and said, yep, we believe it. That's good, and they want to spread the word. Obviously, the internet is a huge place to get your results out there. No matter who you are, where you are, what you've been doing, you can easily share your results on the internet. And then obviously, if you have scientist friends or the people who are interested in what you're doing you can, by word of mouth or an email, something personal, Facebook even, to share your results with other scientists. Now, science isn't really considered true until someone else does your experiment and gets the same results as you did. That's why it's so important to share your results. You might be like, yes, I know this, for sure. But you might have been making that same error every time. And if you didn't document that error, and then someone else tries your experiment, they're like, I didn't get what you got. Now, everything that you've gotten, all that data, it's a little bit less strong. So you need to make sure, if you're trying to really prove something, and scientists do this all over. This is why they have the peer-reviewed journals. This is why it's so important that they share their results, because they can't confirm anything as true until tons of other scientists have done it the exact same way you did and gotten the exact same results you did.